Okay, so today we're solving more radical equations. It's an extension of what we started learning on the last notes, okay? And the last notes were really short because really the only new thing was that you had radicals, square roots, or cube roots in the problems, okay? In order to undo those, you just square or cube the problem, okay? So this is going to be, like I said, an extension of that, a little more new stuff. Number one will be square root of 2x plus 7 equals x minus 4. And if you remember from last notes, what you want to do is get the radical alone on one side of the equation first. Okay, and this one is square root. Okay, it doesn't have a number right here, but I suggest write the number there so you remember what it is. Okay, it's not going to hurt anything. It actually helps. I know a lot of people ask me, like, what is it if there's no number there? Because once we started doing it with numbers, it's kind of easy to forget. Okay, just fill it in. Make your life easier. Okay, so we've got square root of 2x plus 7 over here. How do we undo the square root? We square it. Okay, that's how you undo it. We want to take that off and get the x by itself. We're going to square it. We have to do it on both sides. Okay, now the difference of this and what we did last class, I'm going to break this out, is on the last notes, we would just have a number over here, just one number on the other side, right? And you just square that number and get the answer here. Here we have a binomial. Okay, so we've got to do x minus 4 times x minus 4. So we're going to be going back to some stuff that we did last 6 weeks where we need to multiply this together. So you could use FOIL, or what I'm going to do is multiply using the vertical method because I like that one the best. Okay, but you've got to square this. So when you square a binomial, we're going to get a trinomial answer right here. Okay, so I'm taking it off to the side to work this part out, to square it. So negative 4 times negative 4, positive 16, thank you. Negative 4 times x, negative 4x. Okay, then remember we did this times this and that. Then we put our 0 here, and we do x times negative 4, negative 4x, and then x times x squared. Okay, then we add these together. Okay, we just add down. The x squared comes down on its own. Negative 4x plus negative 4x is negative 8x. And 16 plus 0 is 16. Okay, so when we square x minus 4, remember, if there's two things there, you're going to have to get a trinomial answer. So I'm just going to make myself a little note that, this is where I got this. I did a little calculation on the side to get my answer here. And we're going to 7 today. We're doing 7 problems, okay? I think that the first one and the last one are probably the longest. The rest are pretty simple. So now that we've got a trinomial here, we're going to solve it like we did last 6 weeks, okay? Which was, if you remember, move everything to the same side. So make it equal to 0. So I'm going to move my 2x by subtracting 2x. And I'm going to move my 7 by subtracting 7. So that I'll have 0 over here and whatever I get here. Negative 8 plus negative 2. All right, negative 10x, thank you. And then 16 minus 7 is 9. And remember, if you have a trinomial here and it's squared, how many solutions are there going to be? There's 2. Okay, we had 2 solutions. So we learned several different ways to do it. I am going to let us do the shortcut the fastest way on these, okay, using the calculator, using y equals to find our solutions, okay? Just because it's already kind of a long problem, let's just use y equals That's probably usually the easiest way. There's a lot of other ways. You could do the quadratic formula if you like that better. You could factor, right? We learned lots of ways, but again, this way I think is the easiest way, right? And I'll set it equal to 0 here. Then I graph, and we do second trace 5, enter, enter, enter. Okay, so I get one of my answers is x equals 1. Then I'm going to do second trace 5 again, go to the other side. And enter, enter, enter. And get x equals 9. Do y'all remember another way that we could have done it instead of doing second trace 5? Second graph, the table, right? You could do second graph, the table, and we would be looking for where y equals 0. Okay, it gives me 9. The only problem with this is sometimes it's not a whole number. These are both whole numbers. But if it wasn't, you wouldn't be able to see it on the table. Okay, that's kind of why second trace 5 is better, right? It really depends. If on here you couldn't see the numbers were bigger than 10, like see 9 is almost off the screen. If it's bigger than 10, maybe the table works better. Okay, it just depends. So those are my two solutions. Now here's one kind of new thing. We actually did this at the very beginning of the year with absolute values, but they have a possibility that these two solutions work in the calculator, but when you plug them back in, if I plug x1 in for x here, and 9 in for x there, that they may not work algebraically. Okay, that's because of the square root. It kind of funks stuff up. Okay, so we have to check our answer because then one or both of these might not work, and they might be what's called extraneous. So the way to do that is we'll